Good day. Can everyone hear me? Fantastic. Okay. So I'm the field CTO for EMEA from Databricks. What I'm going to cover today is a little bit of shared pain, but also trying to sort of understand how we can connect to some of the business frustrations that my job tends to put me in the orbit of a lot of our line of business leaders, a lot of our executives, people that are trying to solve some of the world's toughest problems with data and AI. So I'm going to take like a bit of a top-down, bottom-up perspective on this. I'm going to start with some shared pain. And we're going to start with something that's a bit of a cliche, right? So lots of you have seen this. What a lot of people don't understand is how much of a pain this was before it became a cliche. So my background, I'm a protein biochemist. I started my career in a lab. I was figuring out how to make sense of massive data sets, even by today's standards. I was taking cryo-electron images. I was trying to grab at little diffraction patterns that were taken where you took a crystallized protein and you did little rotations of 5 degrees. And these patterns made no sense. Anybody that read them, they were like, what are you trying to do? And ultimately, all of it was a lot of plumbing, a lot of time, and a lot of patience, and it was very lonely. You can call me outside for therapy later. And the purpose was drug discovery and environmental bioremediation. So 2 really big problems. And you could never forget about those problems because all of those things kind of made a lot of sense. But we spent a lot of time focusing on everything around the models. The other thing that we focused a lot of time on was back then, we had to build a lot of plumbing. I had some crazy scenarios. Would you believe that like the best programming language for creating helical models is Fortran? There was a system in the corner. I used to have to wire it up, send data across, get a model back. Don't touch it. No one knew how to do anything to it, but Fortran was great for that. I had another one that did Fourier transforms. I used to send a bunch of data over there and get something back. This was just wiring different clusters around the labs. I didn't have cloud. I didn't have any of this benefit. I would run stuff down to a high-performance compute center. I lived in Cape Town. I was kind of squirreling around trying to find any computer I could, anything that had some storage and some processing power. And that's how the toasters that we had to create basically were built back then. It was a nightmare. Today, you don't have to build toasters. You can focus on toast and bread. And I don't think a lot of people appreciate that that is a huge problem that now goes away. Now, coming from the top, over the last sort of 15 years of my career, I've started to get more involved in this idea of scale. How do we take data and AI and solve the world's biggest problems at scale? Now, this is a piece of research that actually comes out of Stanford University. It's profiling a lot of startups and a lot of companies that are achieving hyperscale, but also a lot of companies that are caught in what they call the stagnation chasm. It's where you kind of drop off. You just get stuck. Things around your growth just start to stagnate. You start to drop. You start to get things like the law of diminishing returns. You start to get things like, oh, how on earth do I find more people to start to build more pipelines? How on earth do I get all this funding? And a lot of the reasons are you don't have enough talent. Everything is fragmented, the ecosystem, the tech, the process, the people, everything is fragmented. And the funding, it's not actually inadequate. It's highly diluted. So you can't get that material gain to get you through this chasm and scale up. And I heard Errol talk about it earlier this morning. It actually becomes more about how do I go from 10 to 100 to 1,000. Now, here's a very interesting quote that kind of talks about what is going on in the market today. So there's a battle that's going on between startups trying to find distribution and incumbents finding innovation. Now, what's really fascinating about this is we all focus on the startup side. We all focus on the cool side, these stories of David and Goliath and all of that. But actually, there's some incredible stories out there of companies that have successfully transformed, and they are finding that innovation at scale. And they've done some material things. Some of them are not the most attractive companies in the world to work for. Some of them are doing quite fascinating things and solving some of the world's biggest problems with data. So let's cover one really quickly, right? So Rolls-Royce, brilliant problem. They have 13,000 engines. These get sort of spread around 26 different types of aircraft. Lots of sensors. And traditionally, they had a maintenance schedule, maintenance being a business capability. Remember, we talked a bit in the original keynote about capabilities. These are business level functions, what that company does. And these were very predictable. They want a schedule. So plane comes in every year, gets an annual checkup. We all know it because we have cars, right? We go in for the annual checkup. What you don't realize about planes is when they fly through a sandstorm, that engine needs to be maintained there and then, because trust me, that thing is going to not take off and work very reliably. So a lot of the sensors, they pull out tons of really interesting data. And they're able to really give Rolls-Royce that beneficial maintenance schedule that says, here's the right part for this aircraft when it lands. They managed to increase the lifespan of every engine. They did something else really, really impressive. They were able to reduce 22 million tons of carbon emissions through this. Remember I said, solving the world's biggest problems. So this is a traditional company that's been around for a very long time that has somehow got through the stagnation chasm. They don't have thousands of engineers working on this. So what are they doing differently? Okay, so let's just jump into it, right? Let's agree that MLOps needs to be standardized. We're not going to go into it. We're not going to just go into this whole segue about it. It just needs to work. It needs to work. It needs to work right. So let's come up with a really basic standard definition. MLOps is model ops plus data ops plus DevOps. So this is something that a lot of industry leaders are starting to agree. They're starting to reconcile that you need to join these things together. They're starting to reconcile that it is not a technical problem, it's a process problem, and that there's more to it, right? But they also recognize that while it improves how effective the fragmentation silos are kind of reconciled, what it doesn't do is it might get you to production, but does it get you implementation? Okay? What I mean by implementation is, has the business adopted it and they're using it? Things running in production, great. Is it being used by your business? Another thing that we can agree on is data. We need to get away from the challenge of data sprawl. We need our machine learning platforms to be connected to our data platforms. They need to work much closer together. The data has to be organized so that models can improve in terms of their productivity. These two worlds have to coexist. They have to be brought together. Another thing is that it's about collaboration. We talked about the talent gap. When I was working on these models, I was a team of one. I had to be the data engineer. I had to be the ML engineer. I had to use a whole lot of different coding techniques. It didn't matter. We need to get back to that as teams. Agile teams is about everybody learning from each other. It actually then drives an attractive place to work. It makes people want to work for you because they're solving the world's toughest problems, but they're also not doing any plumbing. Okay, and the third thing, it needs to support the full ML lifecycle. So I'm going to push a little harder than just where we sit today, because I think we can all agree on what these sort of things are. So let's present the first thesis. Okay? Aren't ML models just another form of transform? They're just a trained form of transform. You recognize this, the more you work with them, you're like, hang on a second. ML is just data and transforms. The ML lifecycle is just data pipelines. And wait, hang on. Stepping back, everything is data plus code. we have created so much complicatedness. Not complex, complicatedness, because we can fix it. You've got to manage complexity. You've got to fix complicatedness. So we've created this. So we've got to step back. We've got to think about this in a slightly different way. So let's agree that ML models are just another trained form of transform. The really interesting bit, okay, is how we can start to think higher order on these things. What can we do differently? What is the really big problem that we need to help our business users deal with? This. Do they trust the model? Is the model credible? These are actual quotes I've heard business leaders say. I'm not going to read them for you. You can read them yourself. But funny anecdote, some of the best models I've seen in production, the business, they are just basing everything on their experience. They don't care about the model. They don't trust the model. So how do we build trust? That becomes a far more interesting, far more fascinating area, because then we start to figure out how do we unlock the work we're doing and really enable the capability. So let's explore this a little bit, right? So what are the different things that we need to evolve in our machine learning environment in order to win trust? So the first thing is, let's accept the data plus code thing. I saw a bunch of nodding, so I'm really happy about that. Okay. Let's then jump to a notion called glass box. The black box is a nightmare. No one trusts the black box. Glass box is the way forward. We want transparency. We need to have something that where we can see what's going on under the hood. You might not care how the watch is built, but if you double click on it and show it to a regulator, tick. You double click on it and show it to a business user who has done things in a certain way for many years and you're trying to help them to be better, tick. You build trust through transparency. That is just a fact. It is how it works. Monitoring, that's just the bare bones minimum. Observability, how do I show root cause? These are the really interesting bits that build that credibility and trust. Okay, so let's jump to the next thesis, right? So thesis 2, this debate is insane. Code, low code, no code, right? And there's some solid arguments for it, right? Solid arguments, it's quicker. It helps us address the talent gap. It helps us to move faster. It helps us to address a lot of different things that we have problems trying to get in terms of the scale chasm. Does it build trust? Will it be adopted? Will you be able to get away with your procurement team saying, okay, unlimited liability and we'll take it? That is the challenge that you've got to work your way through. So the question is, why not both? Because actually, if I've got the same models as you and we are competitors in a competing business, how am I differentiating from you? How am I using AI to move the needle forward? How am I using AI for competitive advantage? Yes, you can say my data is different to yours. I'm not buying it. So you need both. It's the same as a build or buy mode. You buy Salesforce because there's no real competitive advantage in sales management. But you build capabilities. If you're a retailer, you're building like assortment planning if you basically know that that is something that differentiates you from your competitors. So there has to be a build and buy. So there has to be both. Do you want to fragment your ecosystem to achieve that? So let's talk about platforms that provide both, right? So double convergence is really where we're heading. We have these two theses and we're presenting them out there. So we've got data plus code and we have this idea of being able to do full code, low code, and maybe no code. I mean, I'm not sure. I'm not totally sold on it, but maybe it's there. But it gives you that optionality. It gives you that ability to get that talent gap solved, potentially. Okay? So let's jump into that a little bit more, right? So we have disjointed silos experiences. We're trying to solve that. And that's bringing these engineering cultures and the data science cultures together. We also have unproductive experiences around all these different arguments in the market. So the way forward is a common standard collaborative platform. Now, I've said standard, I haven't said central. I'm going to repeat this many times. Okay, not centralized, standardized. It's important. Okay, so we call this common standard in Databricks the lakehouse. The lakehouse is an architectural paradigm. It isn't a product. Like N-tier architecture is an architectural paradigm. Okay, and why we are so behind this and why the industry is embracing this is because it starts to give you that unified experience. It starts to give you those total value units for all your data needs in a collaborative environment that brings teams together. One of the key tenets that we use for this is this maturity curve. So a lot of people are on the one side, which is where your historical kind of, I'm looking backward, what's my revenue last week, month, year? But we also want to look forward and have this predictive capability of like, where am I going? What will be my revenue? And this is an important tenet. But what's not said here by joining these two worlds is we're also joining some other worlds. We're joining the world of all these different engineering practices, from batch to CDC to events and to streaming, one code base. We're joining the world of production and distribution of data. So you've got your value chain. We're joining the world of data engineers and machine learning engineers. And this paradigm is really impressive. What makes it even more impressive is that it's built on open technology. So it means that there's an open architecture. Use my architecture to complete yours. I'm your toaster. Focus on the bread and the toast. And for those of you not getting that one, data and AI. But it's an important distinction because ultimately we need to accelerate our progression. Right. So let's agree that simplification is the pathway to addressing the stagnation chasm. So we've unified the fragmented ecosystem. We've solved the talent gap by giving you teams that can work together and learn from each other. So cross-skilling your teams. And you're no longer diluting your investment because it's moving in one direction. It's pulled together. It's actually not, this group gets this money, this group gets that money. Which means that you can focus on the process and the people, which is so much more interesting. Because you've solved the complicated part, and now you can focus on managing the complexity. So what we're starting to see emerge is that once you unify those units, you can focus on how do I organize my teams. And there's two very, very interesting prevailing ways, and this is allowing us as a business to bet on where is the direction of travel? Like, what is the new technologies? What are the big bets that are coming out there, right? So you see that little circle, that little yellow circle. A lot of this, if you think about how open source communities work, there's governance that's created, Linux Foundation, Apache Foundation, but you can do that internally. You can flip the switch. So in effect, you have teams, they're working on standard platforms. Doesn't have to be centralized, can be centralized, where it makes sense, but it's on standard, open standards, which ultimately you're using things that you're deciding, these make sense because there's a huge community. There's a huge contribution base. It's going to outlive proprietary technology. It's got a long tail. And I can focus on how do I bring these teams together? How do I get them to work together? So what Databricks is bringing to the market is what we call our marketplace. And our marketplace is fundamentally built on, again, an open technology. So as part of the Delta Lake project, there is something called Delta sharing. Now, what's special about Delta sharing is it's a secure live sharing protocol that allows you to disrupt one of the biggest pains. And I can tell you, FTP, disrupting FTP, file transfer protocol, if I can do one thing in my career, that is it. I want to kill that thing, I want to kill it dead. because I have so many painful nights when I was early in my career of waking up at 3 in the morning and having to drive in because of a batch job that failed. These are the sort of things that now we're starting to get to. And that's what delta sharing enables for us. But what it also enables is a very interesting new way of thinking about data and AI in the capability zone. So I've got line of business sharing. They're sharing data with each other. You get rid of the factions. They get to own their data. They get to be accountable for their data. They get to be stewards of their data. They get to govern their data. But because it's on an open standard, you've defeated the fragmentation problem. They can share. I call it AKA data mesh because ultimately that's really what it is. But that's really where you're trying to aim for. And it's facilitated through this marketplace. And this marketplace is special because it's all data assets, it's models, it's dashboards. You don't need to be a Databricks customer to interface with that because it's built on open standards. So Trino connects into delta sharing. Presto connects into delta sharing. So you have options. And that's what makes it really special. That's what makes it an open ecosystem. The other thing is you start to open up options around your ecosystem, like B2C, B2B customers. You start to be able to do interesting things like clean rooms, which allows you to do mergers and acquisitions, divestments, a lot cleaner and more frictionless. You start to be able to monetize, which, trust me, in the economic pressures of today, you're going to have lots of your business going, hey, we need to figure out how we turn this thing into gold. Like you keep talking about oil and being the new oil, like how do we make it, actually valuable? But what it also allows you to do is focus on what your business leaders are struggling with. I call it the 3 paradox problem. Paradox of choice. We all know this one. Have you ever seen, tried to choose a new fridge? So many options out there. But think about what your CEO is trying to do when he's making a big bet for his company. Where do I go? There are all sorts of economic pressures. There are all sorts of competition. There's all sorts of regulation. This allows you to focus on how do I help that person to do that thing? The paradox of experience. We all know this, like this is something I'm familiar with. I don't want to try something new. So how do we help companies to evolve, to figure out what's their new game? How do they create new revenue from the capabilities? My favorite example, everyone talks about Kodak. No one talks about Fujifilm. Business capability now pointed at the cosmetics industry. They were a camera company. But that's what a business capability can do. It can redirect, it can be reused, it can be turned into something really valuable. We're enabling that unlock. And the third is the paradox of uncertainty. I don't think I really need to explain this. We live in the most insane time. Using historical forecasts when we're in something that's unprecedented, it's not going to be helpful. So going back to this idea of trust, the key to that curve is addressing trust. As we become more mature, we have to get closer to being trusted by our business users so that our work that goes into production is adopted, accepted, and scaled. And it does really, really interesting things. So one of the things that we're working on right now is what does a more business-centric framework look like for ML program adoption? Like how do we make sure that ML is accepted as a first-class citizen by the business and is accepted and trusted? So one of those main pillars is focusing on how do we get the change management aspect out? How do we think beyond ML ops? So this is something we're working on, something that we would love to collaborate with, because in the spirit of open ecosystems, we really want to elevate and try to change the message. And one of the most important things is our destination is the lakehouse. We want to help you to stop building toasters. We want to help you to realize that vision. We want to help you to achieve that transparency on an open, simple, multi-cloud platform. And we want to help you to solve the world's toughest problems like we have with Rolls-Royce. And with that, I thank you.